Moin! We're diving into the world of 3D print coatings once again, and this time we're talking about resin prints that get a generous layer of copper, gold and silver. Our highlights for this episode? Well, we've got a nice DIY graphite conductive paint, the art of electroplating with few nodulation and getting that perfect polish without grinding your gears. Ready? Let's go! First off, I'm printing some props that I've always wanted to have. I'm using a resin printer from Alligator, which was kindly provided. It boasts a 9K display, minimizing the visible layer lines. FDM prints do work too, but for those not into the layer look, you'd need a whole lot of elbow grease to smooth things out. Today's 3D prints are an interpretation of a quite famous flying lady, Melina's Brush from Elden Ring, a Mora coin from Genshin Impact, and a pendant from Creative Brit. Next up, we are creating the conductive paint. It's going to be made from graphite, as I reckon the ingredients for it are the easiest to source globally. You'll need a mixing container, micrographite. I use 4 micrometer 99 pure graphite here. Also acetone or butyl acetate, and a binder. I've experimented with various adhesives from a specific brand and found that the binder of a 2-component adhesive works quite well. However, others also do the job. Before we mix this up, let's give Hendrik a stern reminder. Hey, seriously now, where's your protective gear? What PPE do you need? A respirator, good. Your eyes are pretty darn important too. They should always be protected. And your skin too. Also, you shouldn't be sitting, always work in well-ventilated areas. And what's up with that black box? Yeah, exactly, get rid of it. It's just in the way. Alright, moving on with the program. So, the paint. I'm not claiming this recipe is perfect, but it's sprayable with an airbrush and works quite reliable. Take 40 grams of acetone and dissolve about 1 gram of binder in it. Let it dissolve properly. Now add 5 grams of graphite powder and mix it well. You can use an old milk frother like I have here, but I recommend against it for reasons. Now it's best to transfer it into small dropper bottles. Super handy for the airbrush. The resin 3D prints need to be smooth and even. I remove the rough edges and use a sanding fleece. It's because electroforming electroplating amplifies any small scratches, etc. That's why having a well-prepared surface is crucial. Now you can start spraying the parts. I recommend applying at least 5 coats, allowing each layer to dry thoroughly and then polishing with a cloth in between. This will lead to an increasingly better conductivity. This conductivity is essential for ensuring the electrolyte deposits evenly and rapidly. Of course, you can also use a rotary tumbler with walnut granules. In case anyone's curious, it's about 0.4 to 0.8 mm grain. Polishing is the key to success. Feel free to check using a multimeter that the parts have around 1000 to 2000 ohms of resistance measured with your thumb's width. Here comes the star of the video, 5 liters of acidic bright copper electrolyte. It's freshly filtered, so let's quickly put the lid back on. For those who aren't familiar with this, you take 1 or more copper sheets, known as anodes, and the electrolyte transports the copper from the anodes to the 3D print. That's pretty much all you need to know. The copper dissolves and saturates the solution, making it reusable over and over again. To prevent the freshly filtered solution from getting contaminated with suspended particles right away, I place the anodes in coffee filters. I rinse these filters with water beforehand, then for stabilization I put them in a fleece bag and attach the back to the container either on both sides or just on one side. This is done primarily to ensure an even coating on the parts. An electric field is created during the process, and this field's effectiveness, especially in copper plating, is highly dependent on geometry. That's why moving the part is beneficial. For this purpose I use a rotary jig. It consists of a continuous servo, a connector and a holder for the negative pole's cable, the cathode. The whole setup is controlled by a small controller, and you can use anything that can be programmed to rotate a servo for this. It's quickly assembled and then placed on top of the container. Now you'll need an adjustable power supply, preferably one that can maintain a constant current. Usually you'll find something written CC and you set it up like this. Limit the current all the way and then increase the voltage. Then adjust the current to the calculated value and you're good to go. The CC indicator will light up, turn off the power supply and connect the anodes with the positive pole. Let's jump right into with this pendant. But how much current should be set? I usually use between 1 and 2 amps per square decimeter of the 3D print surface. To determine the surface area of the 3D print you can use Blender. Import the STL, set the unit scale to 0.01 and with an add-on called 3D Print Toolbox you can directly calculate the current required. And that's how the piece comes out of the copper bath after 4 hours. Remarkably smooth and with very few impurities on the backside. Just to be safe, give it a pass through a finer filter. Not exactly fun. And right away in goes the next piece. Here you can see what happens when you're not meticulously prepared. Well, looks like it might need a bit more polishing. Alright, let's continue. Fingers crossed. Well, there you have it. We've got a bit of a mess on our hands. It wasn't conductive enough and now it's all blotchy. Couldn't make this up. But fear not, I've got a backup print and this one comes out beautifully from the bath. And here comes the last piece. Well, I couldn't rotate the 3D print and just like that I've got field artifacts and wire imprints on it. But no worries, let's fix it. Let's take a look at the pieces. The pendant has turned out beautifully, the figurine as well, and the brooch, it's intriguing. In any case, we're going to polish everything now and then give it a quick round of electroplating to make it perfect. If you have a polishing machine, great, it's sufficient to give the parts a rough sanding. Doing it by hand takes longer. Here, with the coin, I've already started the process. Everything was going well until this thing got jammed and flew across my workshop. Got completely shredded, but on the bright side, let's take a look at the copper coating. I can cut it and measure the thickness. 150 micrometers in 4 hours at 1.5 amps per square decimeter. Now let's quickly make a new one. What's next? The flying lady will receive a nickel coating. The brooch will undergo nickel plating followed by a gold bath. The Mora coin will also be plated with gold, and as for the pendant, it will go through nickel plating, then gold plating and finally silver plating. This is nickel electrolyte. It requires nickel anodes and is quite toxic. This is gold electrolyte. It requires stainless steel anodes and can generate very toxic fumes. And this is silver electrolyte. It requires silver anodes and can stain the skin black for weeks. Yep, you've got it. Pretty potent stuff. So remember to prioritize your personal protective equipment. So the flying lady is going for one more quick dip in the copper bath just to let that final shine settle in. I've got a bowl of distilled water prepared for rinsing of the copper electrolyte. After that she's taking a spin in the nickel electrolyte at around 2 volts In about 5 minutes everything's done and ready, and we can rinse off the nickel electrolyte as well. We're doing the same routine for all the parts now. One more thing about waste. I collect all the leftover materials and take them to the recycling center. The liquids go into containers and I let any paper waste dry out. There's no other option. This really has to be handled responsibly. Gold electrolyte. A little of it is costly and also quite, well, very toxic if it meets up with any acid. So I've banished all acids from the workspace for now. Besides that, it works incredibly well and produces a nice even coat. The brush, the coin and the pendant all take a dip in here and come out perfectly gold. If someone's not looking to splurge on a gold bath, they can achieve the same results using a different gold electrolyte with the brush plating technique. Works just as effectively. The final electrolyte is silver. I'm applying silver over the gold, it just works better. The nickel layer can theoretically be skipped. Here they are all once again before and after. Feel free to check out the other tutorials on my channel, everything relevant is in the description. Drop a lot of comments and all that jazz. Thanks for sticking around to the end. Tschüss.